Hello. So my name is Sneha, and I'm going to be attempting to do a three.js custom Vertex Shader tutorial from this parking lot that I'm in, because this was the only place that I could find that I could like speak out loud that also had free Wi-Fi. I'm on some like museum Wi-Fi right now. But anyways, so three.js is super awesome, and there are some people that are doing like custom vertex and fragment shaders, um, different like tutorials online, but I I guess I wasn't able to find like too many where they're only interested in updating the vertex shader, and because there are lots of people that are doing both like vertex and fragment shader, but like sometimes you just want to use like the basic phong lighting, but you want to be able to do some kind of animation as well. So um, yeah, so hopefully this tutorial should help um, with that. So anyways, I made this GitHub repo called three.js shader demo, and I'll post that link wherever this video is going. And basically it's just a template for anything like three.js related. So let's just start by cloning that. This is also my first tutorial ever, so hopefully it goes okay. Just bear with me. Okay, so just clone this. Might already have a folder called that, so I'm just going to delete it. Okay. Now we can go into this folder, and you can see that it's using like the Node package manager, so we have to install npm install. Okay, so yeah, let's just take a look at what's inside this folder. So this is my old stuff that I was working on. So in this folder, we have the public folder, which has assets, HTML, and JS files. So the assets is it's a monkey.obj. It's Suzanne from what's it called, from Blender, and we're gonna be loading that later into the project. So I saved it in the repo. And then the JS folder has a bunch of just like some basic three.js files that we have to include. And then the HTML, this should have index this is like the basic template. So it says three.js empty template. So you can see that we start by initializing the scene, camera, controls, render, add those things to the window, and then there's an animate function. So this is like just basic. Yeah, so I guess the first thing we can start with doing is just like loading this monkey object. I wanted to do a monkey just because it's more fun than just doing like the spheres. So, alright, so we can start adding code here. So, load monkey object. So we need to use the obj loader to do this. So I sometimes forget the like syntax for these things, but you can just, oh, this is cool shader stuff, shader toy. We can just Google like obj loader three.js. Yeah. Let's try this one. So I guess this is an obj. So I'm just going into the console to look at the source code, and this is the source code. So somewhere it must be loading in obj. Aha, right here. Alright, So I'm just going to copy and paste this code because this is like official three.js code anyways, so it's gonna work. And the indenting is gross, so I'll fix that. So basically, alright, so it creates an OBJ loader. It says loader.load, and then there's a function of the object. So we just, alright, and we don't have these on progress on error functions. I'm just gonna remove that. Okay, well, this is not the right path, first of all, so let's go monkey.obj. Alright, so cool. So now we have this loading thing. But we don't want to. So well, we don't want to add the whole like mesh here. What we really just want from the OBJ is the geometry, because we're going to be adding our own material to it. So let's say, so if child is instance of three.mesh, then we want to make a new, like, so I'm gonna call our monkey mesh. So if it's here, then we'll go monkey mesh equals new three mesh, and I think you pass in the like monkey geometry, which is just going to be here, actually, the child.geometry. And then you also have to pass in a monkey material, which we will define later. So, yeah, let's we won't worry about setting the position of it yet, and then we just add monkey mesh. Alright, well, this is seems very simple, but that's because we haven't really done anything yet. Okay, sorry, I had to pause because somebody parked and I'm embarrassed to talk out loud. There's someone here. Okay, so anyways, so now, okay, let's start defining this monkey material thing. So, just do it up here. So, monkey material. Alright, so monkey material is going to be, it's going to be a new three, I think it's called just shader material. What happened? Shader material. And inside here, there's a few. Let's just actually look at how to define a new three shader material. So kind of like this. So this is exactly actually something like what we're going to be using. So I'm just going to copy and paste this here for reference. Alright, so you can see that they have, one second, this indenting is ridiculous. I'm gonna rewrite this anyways. So you can see that in the shader material, you provided some uniforms, a vertex shader, and a fragment shader. So this is good. I'm sorry for this noise. This is what happens when you do this in a parking lot. Um, so uniforms are basically variables that you can pass in from your three.js code into your shaders. So this is very important stuff, but we're not going to use this uniform. So what we're going to do is just have we're going to have a uniform, and I will define this later. For now, I'm just going to call it n uniforms. Okay. And then we're going to need a vertex shader. So here we can basically use this exact same thing here. We're not going to use a fragment shader that we're going to write on our own, because that's the point of this tutorial. I want to use the phong shader, but we will come back and fill that out later. So anyways, alright, so what should we do first? Let's define this fragment shader. So basically, there's like a utility where you can just create like a phong shader on its own. So let's do that. Equals new 3 phong shader. Let's wait. Double checking. Build phong shader from 3 phong shader. Yeah, this is what we want. Okay, so we're at phong shader here. It's in the shader lib, and this comes in 3.js.min, I think. You don't have to include anything else. So we have phong shader from 3shaderlib.phong. We have, so yeah, and then you can just get the uniforms that come with the phong shader. So these, remember I mentioned that uniforms are just things that you pass in from your code, your JavaScript code, to the shader. So when you're using phong, there's lots of things that you can specify, such as your like specular color for the material, your diffuse color, your emissive color, like if you want the thing to be double-sided, like all of these uniforms are already included in phong shader uniforms, but you have to specify them if you want. But right now we'll just have a basic shader that we won't specify anything yet. So we've got this phong shader. So in fragment shader, we're just going to say phong shader dot fragment shader. So yeah. Oh, and our uniforms, we'll just use the phong shader uniforms right now, because that is all that we're using. We'll start adding things once we get there. So, alright. I wanted to... Okay, the next thing will be to just start with making a really, really basic vertex shader. So we're gonna call this thing Vertex Shader. Sorry. Okay, we're gonna call this thing Vertex Shader, and the type is going to be... Why does that not work? So yeah. Okay, so we're gonna call this, make a little script, because basically a vertex shader is just like a string of text. So we can just define it in this little like HTML script thing, and then that's why over here we say get the text content from this element. So we have type is type something. Okay, and then let's just do the end. Okay, so the shader is like written in C. Well, not C, sorry. It's a language that looks really like C, but it's called GLSL, which is Graphics Library Shader Language, I think. Kind of guessing on that. But anyways, so it has a main function, and so there are variables that come like, or attributes that come like predefined with when you have a material, and those are like going to be, okay, let me start from the beginning. So the vertex shader gets called on every single vertex point of your object at each render function. So if you want to change the position of your like mesh, then you can change it here, and this yeah, it'll get called on every single point at every render. And it's very like, none of the code depends on anything else, so you can very easily like do this in parallel computing, and like have every vertex like run on a different thread, and that's why it goes so fast, because this is like, it's like an individual block of code that is run on each vertex. I hope that made sense. So anyways, so you get some things predefined, like you get this thing called position, which is just the position in 3D coordinates. But what we want to do in the vertex shader is set this thing called GL position. And it's not just equal to the position, because this is in 3D coordinates, but you need to like you need to transfer it into the view position, which you can do by multiplying model view matrix times p. But I don't think this will work actually, because model view position is vec 4. So model view matrix is going to transform it from, it's like a transformation matrix that takes it from the scene coordinates into your like view coordinates. So we're actually going to do, this is going to have to be a vec 4 of p and 1.0. So that's our model view position, and then to set the GL position, you can multiply, I think it's called some kind of projection matrix. I think it's just projection matrix. I'm not sure about that, but it should be. So projection matrix times model view position, and that will get you your GL position. So this is like a very, very basic vertex shader that doesn't do anything. But let's see, I think we have like most of the things. So let's see what happens if we run this. So basically in here you can say node main.js, and then we'll go here to 83. Oh my gosh, there are so many errors, and I was expecting that. So what it's saying here is that variants with the same name but different type or statically used variants in Fragment Shader are not declared in Vertex Shader, v normal. So what this means is that so there are some variables that a Fragment Shader needs that must be predefined first in the Vertex Shader, because for each point you first call the Vertex Shader to find the position, and then you call the Fragment Shader to set the color. But some variables need to be like passed on to it. So apparently in the Fragment Shader, it's expecting something called v normal. So we have to define that here. And we kind of already like know what that is. V normal is just going to be it's just the normal, but the thing is that it's not one of the predefined things in the Fragment Shader, it's just in the Vertex Shader. So let's just set that. But there's going to be more. So now here, still can't compile. Why? Uniform is not a property of this material. Okay, 1 second. Expected invariant error. Oh, I didn't even declare it. My bad. Click 3. Email. Okay. This should work. It still won't work. It'll be closer. Okay, view position. This is also something that we can get easily from here. So, oh, by the way, they're called varying vectors. I need to close, so I don't have, I'm gonna run out of battery soon, but hopefully, let me just close all these other things so that I don't run out of too much battery. Okay, so, the next thing, okay, varying variable is like, it's like it's a type of variable that gets passed to the fragment shader. So the next one was view position. Okay, so let's do here. So I think it's a vec3. But view position equals model. This is just the model view position. The view position is like your view of this to the scene. So you can basically assume that the center is 0. So you can say that your view vector is going to be like the negative of your view position. And this is used to calculate like specular highlights and stuff. Whoa, it worked. That's weird. That's fast. Okay. Three.shader material uniform is not a property of this material. Really? Three.shader material. This is in line 4. Maybe it's, I think it's uniforms. Do we have this here? Wait, 1 second. Just make sure. Oh, uniforms. My bad. Okay. So looks like it's working. I'm gonna steal some lights from my other code because we still can't see anything. So we want to add some. That's a really bad place to add lights. I will add lights here. Okay. So, where am I? Let's see it again. If this works. Aw, it still doesn't work. It's upset about something. Why is it upset? Cannot read property position of undefined value. Did I do something really dumb? Let's see. Alright, I'm gonna put some breakpoints and see what's going on. It's a really running. Okay, 1 second. My battery's gonna die. Okay, I'm back. Yeah, my battery died. You can see that I'm saving it now at 1%. But anyways, now I have my charger and I'm in an office, talking room. I still feel weird talking though. I feel like I'm supposed to be quiet in here. Anyways, okay, so we left off here because I should probably move this little video box so you can see this. Anyways, it was saying cannot read property position of undefined. That is actually referring to the light's positions. I remembered. So there's another property of shader material that you have to specify that you're allowing the shader to access the lights. So you say lights are true, and this should do something. Or it should just break. Yay! Okay, no errors. But we also can't see anything, so that's weird. Let me, so lights are true. I guess the other thing that you might want to do is just, move our camera a little bit, because the monkey is supposed to be placed in 0, 0, so let's just see if we move the camera back. That does anything. What? There it is! Oh my gosh! So there's Suzanne. Yeah, cool. So the thing that I noticed before is that when you use orbit controls and for some reason they're stuck at 0, they kind of it's sometimes hard to basically it continues to go down into its target point, and if it reaches its target point it feels like it goes exponentially slower into it. So that means it takes you exponentially longer to get out that position. So that's why I just set Z to -5. So cool, we've got Suzanne. But there's another cool thing that you can just add here. We can make him double-sided. Let's see if that works. So now when we go inside, we should be able to see him, but okay, the other issue is that you can see that the emissive color is just black. So let's try changing that. So for that, we have to go and make our own set of uniforms. So let's say uniforms equals, and so in order to help you understand which uniforms you can change even in the phong shader, let's go in and just look at what they are. So I'm just going to console. This helped me realize the things that you can change and what you can't change. So, alright, so here we have all of these different things that you can change. So we can change alpha map, directional lights, emissive. That's the thing that we want. Yeah, so point lights, this is the list of point lights that it gets. Cool. So yeah, you can look at that if there's something that, because there's lots of cool properties of the phong shader, but I just want to change emissive right now. So what I'm going to do in here, go back here, let's create emissive, and I think it's like this. So type is going to be a color, and value. Okay, sorry about that. So type is C for color, and value, I don't know, what color should we make our little monkey. I'm gonna go to color hex codes. What? No, just hex. This is my like. There's like lots of cute colors here sometimes. How about green? That looks fun. So let's click this. So the value is going to be a new 3 color, and I think you just like provide the hex code here. Okay, so now we have our own set of uniforms, but we can't just like specify this. What we need to do is combine it with the other like phong uniforms. So what we're going to have to do is I'm going to comment this out. So we're going to call our uniforms, our combined uniforms are going to be uniforms for monkey uniforms. And we're going to do 3 uniforms util dot merge the phong shader uniforms and the uniforms that I just created. So now if you replace phong shader uniforms with m uniforms, that should contain all of these things. Let's see if that works. And it's green. Cool. It's like pretty bright green. Actually not too much fan of this color, but that's okay. Actually, let's change it. I'm gonna be annoyed by it. Let's do this nice blue. It's too bright. X. Okay. Cute. Much cuter. Aw. Okay. We can also add like specular or something. That might be fun. Okay, let's do that later. Actually, let's see. Specular. So that's gonna be the exact same thing. What if we do specular like red or something? It's gonna look bizarre. What? I forgot something. Comma. Well, you can see there's like tiny tint of something pink there. Right? Yeah, you can. Whoa, that actually looks cool. Anyways, so now we've got Mrs. Specular. So now you know how to basically update any of the phong shader uniforms. So you just have to make your own and then merge them with phong shader uniforms. Make sure that uniforms is second here, because if you put uniforms first and then phong shader uniforms, then you basically overwrite the things that you just set. Okay, cool. So now let's try like, the whole point of this was so that you can use the phong shader uniforms, fragment shader, the phong shader, fragment shader, and be able to update your own vertex shader. So let's try updating our vertex shader. So we probably want some kind of like time element in here. So I'm gonna call it like time delta, and we can have the type be a float, and let's have just like the value start at 0. So now we've created something here, but we need to be able to set that. So let's just have it be like the time elapsed. Yeah. So I'm going to create something here called var time delta equals 0. Wait, no. Let's do var start time equals date dot map, and then var time delta equals 0. This is just for starting. And then in the animate function, we're going to need to update the time delta and send the new time delta to the vertex shader. So let's update time delta first. So time delta equals date.now minus start time. And this is not going to pass into the vertex shader. What you need to do to have the vertex shader update is manually go in and like update that variable. So we have to go, its name is monkey mesh dot material dot uniforms dot time delta dot value equals this new time delta. Cool, so now we should be passing in a time delta, but just so that we know, time delta is in like milliseconds, so the values are going to be really large. It's like, I actually don't know, it's like from the beginning of, actually not sure what time delta refers to. I just want to look that up real fast. Not time delta, sorry, date.now. What is it? Oh my gosh. Okay, yeah. So it's the number of milliseconds elapsed since January 1970. So yeah, these are really large numbers. That's just to keep in mind when we start doing some calculations in here. So now we have these varying vectors, and remember those are getting passed on to the fragment shader. But we also now have something. We have a uniform called time delta. So let's just try moving the thing, the monkey in the x direction or something. So sorry. Okay. I was trying to think about how to do that now. So let's try setting p, changing the p variable. So p plus equals, let's do like sine of time delta divided by 1,000 or something, because these numbers are really big. So not the whole p, let's do px plus equals. Well, I don't really know what this will look like. It should hopefully move it. Time delta is undeclared. Oh, my bad. Uniform floats. Yeah. It's moving! Oh my gosh, that's so cute. Okay, so you can see it's moving kind of like in the sine pattern. Ooh, that's weird. For some reason it's saying double-sided. We're still not getting double-sided. Maybe there's no capital mark. Capital here. Let's try. Double-sided. Oh, look it up. Let's see. Shader. Oh, of course. It is double side. Oh, double sided. What did I have? What? I think I had a graphic. Okay. This is important because double sided is cool. There's lights. Really? That's weird. I swear I had this. Oh. I think it's different. Okay, I think it's like this. So it's actually side. Right? The side connector. Okay, well, this works. Sorry, I had to double check. This should work. Let's see if it does. Ooh, double-sided. Nice. Okay, cool. So now we have like this cute little monkey bobbing. But let's see if we can like do something, do like a kind of weirder animation. So I'm gonna define like the center of this thing to be just 0, because you need to make sure. So in these kind of geometries, there's like 3 vertices that are at the same point. So you want to make sure that your calculation has like no it will make sure that all 3 of those vertices move to the same location. So what you can do, since those 3 vertices, they're given different like IDs, but they have the same position. So you can just like do some calculation that will be the same for all of them based on their position. So I'm just gonna do center, and if you do like maybe the distance, flow distance equals the length between center and P. So this will be the same for every vertex that's at the same position. So let's do like, so now we have distance. Let's just like add that as a term here. Yeah, let's see if that works. So this should do something weird. Ooh, nice. Oh my gosh, that's weird. That's really bizarre. You can also like, you can scale it somewhere like that. Just dividing that by 2. Maybe we can make like the whole. So if you just do plus equals to P, then we'll just add this number to everything. Whoa. Nice. Yeah, anyways, so that was a weird hand movement that I just did. Yeah, keep in mind this is the first tutorial that I've ever done, so it's probably very awkward, but okay. So yeah, I think that is the gist of it. So now you can like do whatever you want here in this Vertex Shader, but I think it's cool that you don't have to rewrite any of the lighting stuff, because if you just want basic lighting, then you shouldn't have to write like all the light like calculations. They're not too difficult, really. Actually, that was like my first attempt at doing it. I wrote my own like phong shader, and it was definitely a learning experience, and it was cool to like see how you do like basic light calculations, but it's really not necessary because my result looks like just like the phong shader result, but with none of the uniforms really. So this comes with so many cool uniforms already, and might as well just use all the work that three.js has done here. Um, yeah, so I will be posting this online, the filled version as well, and yeah, I hope that that was helpful. And if anyone has questions, you can comment or contact me, and contact me like wherever on GitHub or my email, or yeah, and yeah, I love three.js, and I'm gonna keep working on projects on it. And now I'm just rambling because I don't know how to end a YouTube video, but or tutorial. But yeah, hope it was great, or hope you learned something. Okay, bye.